learn from the fundamentals and we'll start from the scratch that how you can utilize emu8086. First of all, it is emulator. So currently, suppose you are working on Intel i7, but you want to feel that you are actually working on 8086. That feeling will be given by this software. That's why we are gonna use it. Understand? So in our example, whenever you open your emulator, click on new. You are having 4 options. We are going to utilize exe template. So we'll choose exe template and it will give you something like this. So your emulator will look like this. Done. Now as you can see over here, whatever is available in green color is your comments. And if you want to write down comments in emulator, semicolon, you can write down whatever you want to write down. Okay. As you can see over here, we are having 4 segments in 8086. So when you write down your code in code segment, you also want to use other segment, you can utilize it. So this is data segment, stack segment and code segment. Understand? Currently I don't need any of this, so I am deleting this. Okay. Now segment is my assembler directives. It will tell me that this is my logical segment. Start is a keyword. It is not assembler directives. It is like main in your C program. So your compiler goes to main and start executing your code in C language. Same way, assembler first go to start keyword and then it starts executing. Understand? Okay. Then these lines are also not needed. So I am deleting these lines. Now, move AX, 4600H, INT21H. INT is the instruction which is used to generate the interrupt. Interrupt is generated to stop your operating system. So at that time you want to take control back to yourself, right? You want to take control to your original code. So here your program will get stopped. That's why these 2 lines are needed in each of your code segment. Ends is again the assembler directives which tells the segments ends. And end start is the end point of your full program. So after that, whatever you write, it will remain unnoticed by your assembler. Understand? This is my basic program which is needed every time. Now suppose here I can write down my code. If I write move AH, 55H, this is 8-bit instruction. How you can say that it is 8-bit instruction? Because of AH register. Same way, if I write move AX, 6677H, this is 16-bit operation. I am transferring 16-bit data into AX register. A is a register which can be utilized as 8-bit or as a 16-bit depending on your requirement. H is written to indicate the numbers are in hex. Your full microprocessor is operating with hex numbering system. Okay, keep in mind. So if you click on emulate, this is original source code, we don't need it. Now make it full screen. This is your actual architecture of 8086. Here is your original source code. The right hand side is your source code. This is my code segment and this is my offset address, IP. This is CS, this is IP. If you check your CS right now, it is 0710. The leftmost portion is your registers. Inside your microprocessor, there are this many registers available and you can check all your registers. Now, because of some reason, you are not able to see it fully. So, let me make it like this. I think now you can see. So, here is your segment all registers. This is your microprocessor inside containing these registers. As you can see, AX, BX, CX and DX are having 2 parts. So they can be used as AH, AL, 8-bit registers also. These are all 16-bit registers. How you can get 16-bit? Because it contains 4 digits. 4 digits of hex. That means 16-bit numbers. Understand? Yes. And this is my memory. Microprocessor is different thing. Memory is different thing. Okay, you have 1 MB of memory. Why 1 MB of memory? 20-bit address bus. Yes. So if you can see over here, this is my segment address, this is my offset address, and this is my memory address 07100. This is 20-bit address, 5 digits of hex. Yes. And on one location only 8 bit of data available. B4 is 8-bit number. 55 is on location 1, 8-bit number. So in each location you can store 8-bit of data. Understand? Yes. So this represents your memory. This much thing is okay. Now this blue line indicates that currently my IP is pointing on this line. When your IP is pointing on some line, that means that line is not yet executed. IP is always pointing to the next line to be fetched. IP is always pointing to the next line to be fetched. So this is not yet fetched. So when I click on single step, now this line is executed. Understand? And my IP is pointing on next line. Move AX, 06677H. Understand? And so IP is pointing on this 0002. Check your IP. Again it is 0002. So you can verify here also. And this blue line in memory contains 3 locations, 02, 03, 04. What that means? This instruction is of 3-byte instruction. Understand? Yes. So 66, 77 is my data and B8 is my opcode for that move instruction. Understand? Yes. So move AX, 6677H is 3-byte instruction. If someone will ask you, you can say it from this diagram itself. Yes, look from this. Now check your AH. It contains 55. Yes. Now if I do single step again, it will transfer 6677 in your AX. Done?
Yes.
Now how AH will contain 66 and L will contain 77? Higher byte, higher address, lower byte, lower address. Little Indian rule which follows. Done? Now AX will contain 4C00H. Done. Interrupt will get generated. Now BIOS will comes into picture and program halted. This is what happens. Understand? Now let's minimize this. Come back to our original code. Okay. Now I want to create data set. Now as we know that you can give any name. Suppose I am giving Sapan as the name of my segment. Okay, it ends with NS. Currently this is my segment. We don't know it is data segment or code segment. You need to tell your assembler that this is my data segment. Understand? So I can define anything. Suppose I am declaring one variable called A. Here I am writing DW. What do you mean by DW? Data word. So we are occupying 16-bit. Understand? So if I write C, 55H, concentrate over here, 66H, 77H. Though, sorry, here it is 55. Though these are 8-bit numbers, but because we have written DW, it will store in 16. So 2 locations will get occupied. In one location there will be 00, in one location there will be 55. Understand? Okay. Where 55 will get stored and where 00 will get stored? 55 is lower address, 00 is higher address. So on location 00, 55, 01, 00, 02, 66, 03, 00. Understand?
Yes.
That's how your data will get stored. But if I run like this, it will not store the data because your assembler don't know that there is a segment called Sapan and it is a data segment. So you first need to tell your assembler. So for doing that, there are 2 lines that you are supposed to write. Move AX, Sapan, move DS, AX. Now this will tell my assembler that there is a name called Sapan and it is actually my data segment. So if you go over here, click on emulate, done. Now go to your emulator here. See, currently what is my data segment? 0700. So if I go here 0700 and 000 is my default offset, if I press enter, it's a garbage. Currently no data segment is assigned officially. But when these 2 lines will get executed, after my AX value will go into DS, officially my data segment will get assigned. So if I click 2 times, now see your DS is 0710. This is my actual data segment. So if I click over here 0710 and if I press 0000, The answer should be 550066007700. Enter. Just check over here. 550066007700. Why it is that? Because of DW. The same thing I am using DB, only 8 bit will get occupied. So 55, 66, 77. It would be like that. Just check. If I am doing instead of DW, if I am writing DB, now it is data byte. Only 8 bit will be get occupied. Click emulate, minimize this, click 2 times, DS is assigned, go to 071000000. First 3 location 556677. 556677. Understand? So this is the difference between DB and DW. Okay. Now by default your data is stored from the offset 0000. Understand? So if I am declaring variable B DW 11H, 22H, 33H, from where my B array will get started. B array will get started on location 0004 or 3. On location 0055, location 1 66, location 2 77. So B will start at 0003. Understand? On location 0003, 11 will get stored. On location 4, 00 will get stored. 5, 22, 6, 00, 7, 33, 8, 00. And if I declare one more variable C DW 1122 9876H. So on location 9, C will get started. Understand? And on location 9, lower byte is 76 will get stored. On location 10, 98 will get stored. Understand? How officially. So if you go to emulate, come here, check this. Now if I am doing 2 times single stepping, my DS is assigned 0710 and here it is 0000. Press enter. 556677 2. On location 3, 110022003300. On location 9, 76. Location 10 is A in hex. It is 98. Complete?
Yes.
So now you understand how your data segment works. Clear?
Yes.
So if you want to check your memory, you need to go to this middle part. If you want to check your microprocessor, go to your left hand side, all registers, and you want to see your original source code, here is your source code. Understand?
Yes.
Clear? Now this is which addressing mode? Okay, now let's take the example of addressing mode. Try to understand different addressing mode. Okay, so I want to store, suppose 1, 2, 3, 4 into AX. This is my task. What I want to do? I want to store 1, 2, 3, 4 H into AX. The simplest method is move AX, 1, 2, 3, 4 H. This is called immediate addressing mode. Your data is directly available inside your instruction. You are directly transferring into AX. Understand? This is one. Now move BL, 34H. Move BH, 12H. Move AX, BX. Now this is also doing the same thing. Understand? This is 8-bit operation, immediate addressing mode, BH, 12H, immediate addressing mode, 8-bit operation. But this line move AX, BX is 16-bit operation, register addressing mode. You are transferring data from one register to another register. The left hand side is your destination, right hand side is your source. So data is copied from BX to AX. Understand? So again we will get 1, 2, 3, 4 into AX. Clear? Whenever you are using square bracket, that square bracket. Now by default, if I writing this square bracket 100, what do you mean by this? This is a memory location. This is the offset that you have written, and by default memory is depending on data segment. So this is nothing but DS colon 1000, comma. I am transferring 1, 2, 3, 4, H. Is this instruction correct? Yes, it is correct. What it do? It is 8 bit or 16 bit? 16 bit. Why it is 16 bit? Because 1, 2, 3, 4, H is my 16 bit number. It will get stored on location 1000. So on location 1000 only 8 bit data will get stored. So on location 1000, 34 will get stored. On location 1001, 12 will get stored. Understand?
Yes.
And if you remember aligned memory and misaligned memory, this full operation will get performed in single clock cycle. But instead of this, if I am writing like this, though this is again 16-bit operation, your processor is capable of doing 16-bit operation, but this operation will require 2 clock cycle because the number is odd. This is called misaligned data. Your 34 will go in 1, 12 will go in 2, but it will go in 2 clock cycle because you are having a memory bank concept. Understand?
Yes.
If you don't remember, go and watch that video. But this is your which addressing mode?
Direct addressing.
You are using direct addressing mode, right? Or instead of doing this instruction might not work. Let me do move square bracket. Okay, why to do this? Because our BX is already containing 1, 2, 3, 4, right? So let's do it BX. Done. Now this is direct addressing mode. Clear?
Yes.
Okay. And if I am writing move AX, comma, square bracket BX, what happens? BX will containing 1, 2, 3, 4, H. So on location 1, 2, 3, 4, H, whatever is stored will get copied into
Yes.
AX. That will not copy 1, 2, 3, 4.
Yes.
Keep in mind. So suppose move square bracket 1, 2, 3, 4 H, comma, I am storing 4455 H. So this 4455 will get copied into AX after this. Understand? Let's see how many instructions are correct and how many are wrong. This is your indirect addressing mode. Last one is. Understand?
Yes.
Let's see. Will it work? Okay. We have not received any error, so that is fine. Now, first is data segment will get assigned. Your DS is 10710. IP is this. AX will contain 0, 1, 2, 3, 4, H. Immediate addressing mode 1, 2, 3, 4 is available in AX. Yes? Now BL will contain 34. Yes. BH will contain 12. Yes. Now full BX is containing again 1, 2, 3, 4, which comes into AX. It gets overwritten. It is simple, right? Now 4455 will copy it into location 1, 2, 3, 4. It is copied, but how can we confirm it? We need to go to that memory location. How to go to that location? 0710. And what is the location? 1, 2, 3, 4. The number is even. So memory is aligned. The operation performed in single clock cycle. Understand? And if you go to that location, 4455 is stored, 34, 55 is stored, 35, 44 is stored. Lower bit, lower address, higher bit, higher address. Very simple. Yes? So means data is available, data get transferred. This is your direct addressing mode. Yes?
Yes.
Now next is BX is copied on location 1001. We have written 1001. Okay, let's see. Will it get copied? Okay. BX માં શું હતું? 1 2 3 4. એ લોકેશન માં આવી જવું જોઈએ 1001 પર. કેટલા ક્લોક સાયકલ માં ઇન્સ્ટ્રક્શન થશે? 2 માં. Let's go here 0710 and we need to go to location 1001. Yes? It should contain what? 34 or 12? Pehla 34. Lower byte, lower address. Then 12. So 34 and 12. and it is available 34 and 12. અહીંયા જોવાનું. Yes. Last is bx માંથી ax માં. bx is containing 1 2 3 4. Yes. So in this location, on location 1 2 3 4, we have stored 44 and 55. So ax will contain 44 and 55. Understand? Yes. Initially it is stored 55. So 55 will go into al. 44 will go into AH. So your number is 4455 into AX after this instruction. Check your AX. So yeah, correct. Yes. So this is how you can check your addressing mode also. Done? Okay. Now you need to tell me something. If I am writing this instruction, LEA AX comma B, what is the value that get copied into AX? First, what is LEA? Load effective address. So it will store the address. Address is offset address because our 20-bit address we can't store somewhere, right? When I say address in 8086, there are two addresses: physical address, virtual address. In physical address, 20-bit address, we don't use physical address. Your microprocessor use it. Okay, how it find it out? Segment address into 10 plus offset address. That is your physical address. We always use virtual address. In virtual address also, we hardly use segment address because it is fixed. We only use offset address. Offset address is of 16-bit. Yes? Don't look at me like this. Where is this? This is my memory. We are not writing physical address. We are writing this address. This is my segment address. This is my offset address. This is 16-bit address. This is again 16-bit address. Understand? Hex numbers are there. 4-digit, 16-bit. This is already fixed. This is decided by your microprocessor randomly. This is decided by us where we want to store, where we don't want to store. Understanding data segment. So this is offset address. So when I am talking about address, we are talking about offset address. Understand? So you need to tell me if I am writing LEA AX comma B, AX will contain the address. Understand?
Yes.
Address is offset address. Offset address is always of 16 bits. So we can't write down AH over here. It must be AX. Understand? What is the offset address of B? So your B is starting on which location? This started on 0 0 0 0. This is 0 0 0 1. 0 0 0 2. So this must be started on 0 0 0 3. So when I am executing this instruction, my AX will contain 0 0 0 3. Let's see. So this is my first instruction, second instruction, done. Okay. Now when I execute this line, my AX will contain 0 0 0 3. Yes?
Yes.
Now go to your data segment. 0 7 1 0 colon 0 0 0 0, enter. Done. This is your data. I have written 0 0 0 8 0. Done. This is your data. Okay. And your array C is stored on location 76 is stored on which location? 0 9. So instead of B, if I write down C, your AX will contain, so now say AX mark 0 0 0 9. Understand? Just check the answers. So if I click single step, it contains 0 0 0 9. So LEA is giving you address. Okay. Now you are having a program to transfer the data or everything. At that time you require. Now if you remember your block transfer program, what you are doing, you are having array 1, you are having array 2, or you want to swap the numbers. How you can do that? Take one pointer on array 1, take another pointer on array 2, take these two numbers, exchange them, increment the pointer. How you can get this pointer? Using LEA. Understand? A 11 22 33 44 55. Array B 10 20 30 40 50. Again concentrate. A 11, 22, 33, 44, 55. Array B 10, 20, 30, 40, 50. Okay, what I need to do? LEA SI comma A. So it will point on 0, 0, 0, 0. LEA DI comma B. So B will pointing on 10. Understand? Yes. Move AH comma SI square bracket SI. So value at the address of SI will get copied into AH. So what will come in AH? 11. Virtually we don't get anything. Explain using examples. Nee? Chalo, let's concentrate here. Array A. First DB 11H comma 22H comma 33H. Okay. Array B 10H 20H 30H. Done. I don't require one more variable right now, so let's remove this. Okay, I want to exchange these two in array. This one thing is okay. Let's take LEA must be 16-bit registers you need to take, right? So source index SI comma A. So SI will contain 0, 0, 0, 0. LEA DI comma B. DI will contain what? What? 0, 0, 0, 3. 0 પર 11 છે, 1 પર 22 છે, 2 પર 33 છે, તો 3 ઉપર 10 હશે. ત્યાંથી મારો એરે B ચાલુ થશે. It is as simple as that. Yes? Yes. Focus. Don't sleep. You are here to learn. Done this one thing? Now, move AH. Why I have written AH? Because my data is of 8-bit only. I only want 8-bit data. I don't require 16-bit register. AH comma square bracket SI. So what happens? SI will be replaced with 0, 0, 0, 0. Yes? Square bracket 0, 0, 0, 0 is 11. So my 11 will get copied into AH. Understand?
Yes.
Enter. Move BH comma square bracket DI. So DI will be 0, 0, 0, 3. On that location 10 is there. So 10 will come into BH. So now AH is 11, BH is 10. There is an instruction XCHG, exchange AH comma BH. Both value will get swapped. Simple. So now my AH will be 10, BH will be 11. આ રજિસ્ટરમાં થયું, મેમરીમાં નથી થયું હજુ. I need to replace it into memory. So move square bracket SI. હવે SI માં શું જતું રહેવું જોઈએ? AH, because AH is replaced. AH માં 10 છે એટલે 0 0 0 0 ઉપર 10 આવી ગયું, 11 ની જગ્યાએ 10 થઈ જશે. આની પછી move square bracket DI એમાં જવું જોઈએ and it will replace with 11. Understand? Let's see this much thing is correct or not. Okay, यहाँ तक तो गलती नहीं है. Done. Yes.
Yes.
Data segment is assigned. Now SI will be 0 0 0 0. Check SI. All zeros, right? Check DI 0 0 0 3. Done.
Yes.
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 Now next is your AH will contain value at SI. શું હતું SI માં? 0 0 0 0. Replace. So 11 will come into AH. Check AH. Yes.
Yes.
Now your BH will contain 10. Yes.
Yes.
Now exchange instruction will exchange the value. So now AH and BH will get replaced.
Yes.
Replaced 10 and 11. Yes?
Yes.
Now I am putting it to SI and DI. હવે ગયું કે નહીં ગયું તેને માટે મેમરીમાં જવું પડે. 0 7 1 0. By default it is on location 0 0. First location 0 0 0 0 will be 10. 0 0 0 3 will be 11. Yes?
Yes.
Enter. This is 10. This is 11. Data get swapped. First part is O. Yes?
Yes.
Okay. Now we are dealing with only 8-bit data. Sorry. So increment SI, increment DI. So now my SI will contain 0, 0, 0, 1. So now it is pointing on 1. And my DI will pointing on 0, 0, 0, 4. Understand?
Yes.
So now one is pointing on 22, one is pointing on 20. Do the same operations again. Huh?
Yes. Yes.
So you need a loop. આ લૂપ ક્યાં સુધી ચાલવી જોઈએ? J and Z. XYZ is my label. XYZ column. This is my loop. Khatam. Program is over. If you click on emulate, go here, run the program. Something wrong we have done. Yes? Why? We are not decrementing anything. So it goes to infinite loop. It will check 0 flag and nothing will get 0. Understand?
Yes.
So what you need to make 0? Your count. You need one variable, right? So suppose DEC, decrement CH. But there is nothing in CH. So CH is my counter. MOV CH, 03H. I want loop should run 3 times only. That's why I have taken this. Huh?
Yes.
This is because J and Z instruction. I can use any register over here. I can use CH or DH. It's my wish. Yes?
Yes.
Let's do it again. Minimize this. Run this. Done. 2 times executed. Program over. Output આવ્યું કે નહીં આવે તે ખબર કઈ રીતે પડે? અહીંયા જવું પડે 0 7 and location 0 0 0 0. What should be the answer? Data should be exchanged. So initially it is 10 20 30 and નીચે 11 22 33 and it is changed. Now you understand how to write down program and everything. This is what you need to do for all the programs. Trace it, check it, and you need to tell me what each program is doing. This is how your emu8086 works. Clear?
Yes.
I hope this is quite clear. Now you can do it yourself. Fine?
Yes.
Thank you.